37. What's the largest value of the following expression? This is quadratic expression. And then the coefficients of the quadratic terms are negative. So recall the parabola. It's very similar to parabolas. So it's something like quadratic, looking upwards or downwards. Since we have negative coefficients, leading coefficients, it will be looking downwards, and then we would be looking for the top of it, right? Because it's already asking for largest value. And recall what we were doing in the parabolas. How do you find the largest or smallest possible value? You need to do completing squares. So how do I do the completing square for this one? So I need to do squares for each variable separately because I don't have mixed variables like x, y, y, z. So it's just x, y, z, and then squares. So for the first one, 20x, let me just take the x minus 2x squared. How do I complete it into a square? So it's multiplied by 2. It's probably will be a factor of 2 here. It's like 2, 10. 10 is like, what was the formula in the completing square? It's like 2ab, right? 2ax. So I need like 2 and 5. So I'm going to write it like as the following. So you'll see why in a moment. I'm going to write this minus 2x squared plus 20x minus 25 or minus 50 plus 50. So you can think about why it's 50 and then try to come up with similar number for the other variables. So if I take out negative 2, I'll have x squared minus 10x plus 25 plus the 50 separate. And then this one becomes minus 2. What's this? It's a square of x minus 5 plus 50. Okay, so we have a complete square here. So this is helpful. So let's do the same thing for y and z. Minus 4y squared minus 4y. So for this one, I can just add 1. So you could add some other number, but 1 is good. Actually, 1 is the way here, I guess. So if you do plus 1 minus 1, this is going to be 2y plus 1 squared plus 1. And then the last one, minus 3z squared plus 6z. So here, minus 3z squared plus 6z, probably that's minus 3 plus 3, because when I take out the 3, I will have this expression plus 3. And that gives me minus 3 z minus 1 squared plus 3. So I have, for all three like pairs, like parts of the original expression, I have quadratic forms, right? So, and then the final with this negative 2 is still there. So my function f of x, y, z now turns out to be the first x's minus 2 x minus 5 squared plus 50 minus 2y plus 1 squared plus 1 minus 3 z minus 1 squared plus 3 minus 2, the final 2. So if I collect all the numbers like 50 plus 1 plus 3, 54 minus 2, 52. And then I get minus 3 expressions like square of something, minus square of something, minus square of something. So these squares are positive, at least 0, right? So which means they are all contributing downwards, like making they are all making the value of function less. If I make all of them 0, the contributions will be 0. So you cannot make it more than 52. So the maximum of this function is 52. It's impossible to make it more than 52 because these 3 expressions, they are all contributing negatively, subtracting. So when they are all 0, so which means when z is 1, y is negative 1 over 2, and x is 5, we get the maximum value of the function, which is 52.